Right, hi guys. I'm going to go through some of the overlap questions. So I'm going to start with some questions that are foundation only. So questions 17 and 18, and then questions 1, 2, 3, 4, 5, and 6 are the overlap questions, foundation and higher. So it would have been, 17, 18, and then 19, 20, 21, 22, 23, 24 on the foundation. And then there's this question 25 on foundation, which only appears on the foundation paper. There's question 26 that only appears on the foundation paper. And then I'm going to go through number 7, number 8, and number 12 of the higher paper. So there will be timestamps in the description. I will try to go relatively quickly, although we're already not off to the best of starts because I haven't got the thing to write with. So I write on this thing. And basically, if you see a question that you actually haven't done, because, for example, you might have done the higher paper and therefore there were some of these foundation questions that you haven't seen. Pause the video and have a go at them because they could have easily appeared on the higher paper as well. Okay, so right, let's get started. So number 17. So if you haven't actually tried this question because you did the higher paper, pause the video and have a go. Right, Riddington and Greenock are two small villages. Population of Riddington has increased from 80 people to 120 people. So let's write that down. So for Riddington, we're going to have 80 going up to 120. And for Greenock, we've got 200 down to 120. And we're wanting to calculate the percentage change. So there are a couple of ways of doing this. I'll talk about both, and I'll try to talk about both fairly quickly. So the first one, and it's the one that I prefer, and you probably know that I prefer it, is to work out what the multiplier is. And then you check to see what that would do to 100%. So if I bring the calculator up, the question is what have we actually multiplied 80 by to get 120? So I do 120 divided by 80. And this is a multiplier of 1.5. And then remembering to all those lessons where you'd be asked, right, so what is a 1.5 multiplier? Well, it's a 50% increase. It's a 50% increase because what it would do to 100%, if I times 100% by 1.5, it'll go to 150%. So that's a 50% increase. Okay. The other way to work out that it was a 50% increase, and I'll mention this now, is basically if I do 120 take away 80, so 120 take away 80 is of course 40. So the actual difference, the actual gain of population is 40 people. There are 40 more people. Now, as a percentage of the original population, because remember this is from the original population to the new population through the increase. So the original population was 80, and of course 40 is half of 80. 40 out of 80 is 50%. So you would get the answer of 50% if you did that. Okay. So let's try this one. So this time, what's the multiplier to go from 200 to 120? Well, I do the target divided by the start. So this is 0.6. So this has obviously gotten smaller. So I'm timesing by something that's less than 1. Because if I times by 1, it stays the same. And if I times by something less than 1, it's going to get smaller. So what effect does that have to 100%? Well, it turns it into 60%. Right? Turns it into 60%. Which is, and this is where you have to be super careful, okay? So careful. because this is not a 60% decrease, it is a 40% decrease, because we started with 100% and now we're left with 60%. And so in the language of percentage increase and decrease, we would say that that is a 40% decrease. Okay, a 40% decrease. And if we apply the other method that I just talked about, well, it's gone down by 80, and 80 out of 200, and make that into a percentage, is 40%. So again, you get a 40. It's 40% of the original has been taken off, which means it's a 40% decrease. So it says, okay, show that Riddington has had the greater percentage change. Well, 50 is bigger than 40. So I think that's probably enough, isn't it? 50% is bigger than 40%. Right, number 18. Andy flies from the UK to Japan. His plane ticket costs £554. So he's going from the UK to Japan, and then he's going to Australia. And so UK to Japan was just straightforward £554. Japan to Australia, we're told, is 70,140 yen. And we're told that £1 is 140 yen. Okay, so what we want to do is we just want to make everything into pounds. We want to make everything into pounds. So let's deal with this one first. So 140, so this is yen to pounds. 140 yen is £1, okay, it tells you that there. So then we've got 70,140 yen. So the question is how many pounds is that? You just work out what you've times by. So 70,140 divided by 140. We're going to see how many of these 140s do we need to make 70,140. And it turns out it's 501. So we're multiplying by 501 to get there. But every time we have 140 yen, we really have £1. So we have £501. Okay, so this is £501. And we might as well work out his total, which is 554, add 501. So he's paid, Andy has paid £1,055 to go from the UK to Australia. Okay. I've got to be very conscious about the amount of space on the screen. So I'm putting this line in here, so I'm limiting myself to here because I know I've got the calculator. So now we've got Leela, I guess, and she's flying from the UK to Australia. It costs 1,860 Australian dollars, and $1 Australian dollar is 62p. So we're just going to do, so this is for Leela or Layla. I don't know how to say that name. Because I knew someone who had this name and they pronounced it Leela, so I'm going to go with that. So she's spent 1,860 Australian dollars. Each of those is really 62 pence. So we're just going to times this by 62 pence. So what's that? That's 1,860 times 62p. And that's £1,153.20. So who pays more, Andy or Leela? Well, it's Leela, isn't it? Apologies to anyone out there who pronounces it Layla or however you say it. All right, I'm not going to get hung up on that. Right, now for question 19 of foundation / 1 of higher. Okay. Right, Oliver records the distance from London to each of 8 cities in the USA. He also records the time taken to fly from London to each of these cities. The scatter graph shows this information. So we've got distance and time. And so if it's a short time, it seems to be for a shorter distance. And if it's a long time, it's a longer distance. Of course, that makes some sense, doesn't it? So Chicago is a city in the USA. Chicago is 4,000 miles. So you look at miles, you go to 4,000. And it says, by drawing a line of best fit, find an estimate for the time taken to fly from London to Chicago. So we're going to put a straight line in. And the key thing you need to remember about a line of best fit is you want about the same number of points above the line as below the line. And it doesn't have to be exact. Okay, the line of best fit that you draw might very well be different to the line of best fit that somebody else draws. Not sure why I can't seem to edit it. Oh, there we go. So let's make it red. Let's make it a bit bigger. Right, so got my line of best fit. Find an estimate for the time taken to fly from London to Chicago. So we're going to go to 4,000 and then use our line of best fit. Now remember, this is an estimate. It's really tricky to draw on this, but it's what, about there? Sorry about the wibbly line, but it's about there, isn't it? So what's that? 4, 60, 70, 80. Now I'm going to say about 490 minutes. I think I should probably load up the mark scheme, to be fair, just to make sure that I'm not making any really silly mistakes. So what was this? It was mock set 3. And I just want the mark scheme. Oh, great. Look, the mark scheme is appearing on there for you. Hey, well, that's good, isn't it? Okay, so 490 is actually right in the middle of what the mark scheme allows. So we'll go with that. Right, we'll go with that. Is that what I need to hide? This one? Yeah, there we go. Okay, great. So why is it only an estimate? It's only an estimate because we don't have the actual bit of data. What this is called interpolation. I'm just going to see what word it says. Okay, so the sort of reasons that it says is that your line of best fit could vary, right? So people could have different lines of best fit drawn. The data is only a sample. The scale cannot be read exactly. There's lots of reasons it's an estimate. The main one is we don't actually have the bit of data for Chicago. So I'm not going to write anything in there. I'm just going to say that. Okay, there's like lots of reasons we can give. Calculate the gradient of your line of best fit. Okay, so gradient equals how far up divided by how far along. So we just need to pick some nice coordinates. It's not very easy on the screen though, to be honest with you. What I'll do is I'll actually make this line start there and go up to there, and then at least I can say, I mean, it's probably got to allow this. So how far up have we gone? See, what we can say is, how far up is it? 6,000. So everyone's answer to this will be slightly different. That's the problem with going through a question like this. Everyone's answer is going to be slightly different. You just need to you know, go some amount along, go some amount up, work out how far up, work out how far along, being careful of the scales, and then do the up divided by the along. So I'm just going to pretend that this was my line of best fit. I know it's not quite right, but the gradient won't actually matter if you think about it. If I move it along a bit, it's not going to affect how steep it is, okay? So I'm just going to use this as my best estimate because of the nature of trying to do it on the computer screen, all right? It would be easier on a piece of paper that's actually been properly printed out for you. You need to work out how far up. So I'm going to say I've gone... Oh, I've got to be careful though, haven't I? Because it's starting at 3,000. So it's not 6,000 up. It isn't 6,000 up. See how careful you got to be, look. Starts at 3,000, goes up to 6,000. That's 3,000 up. And then how far along? 400 along to 700, I'm going to say it's 300 along, right? 400 along to 700 is 300 along. And then that's 10. So let's just see what the mark scheme says. Does it allow 10? Well, no, it doesn't. It says 9.4 to 9.8, but I think if I was being more accurate, and if I actually had it in front of me and I actually had a ruler and stuff like that, I could have been slightly more accurate. Hopefully I've explained this in enough detail. If you are stuck on gradients and don't understand gradients, I've got loads of videos on gradients, including a playlist on them. You really are just working out how far up have you gone divided by how far along have you gone, okay? For example, if it's still time along the bottom, but this is like saying miles per hour, right? This is like saying miles per, well, I suppose it's minutes, but a gradient is a bit like a speed, okay? A bit like how fast are you going. Anyway, maybe the less said on that, the better, because I don't want to confuse people, but whatever. Give an interpretation of the gradient of your line of best fit. What shall we say? So this means when for every minute you go 10 more miles. Is that a fair thing to say? Let's have a look. Gosh, I'm overcomplicating it. It's what I was saying before. It is just the speed. It's the speed in miles per minute. So yeah, don't overcomplicate it. The up is being measured in miles. Yeah, miles is the up number. The along number is being measured in minutes, so it's literally miles per minute. But that's a type of speed, isn't it? That's miles per minute. So I'm just going to write the word speed and be done with it. Okay, I wasn't saying anything that was wrong there. It is true that for every minute you're doing 10 more miles or 10 miles per minute. But what I was not doing was saying it simply enough to just write down that that's a speed. Okay, so there you go. That's the answer to that one. Okay, number 2, or what number is it really? So 18, 19, 20 on foundation. Rotate shape S 90 degrees clockwise, center 5, 4. So we go to 5, 4, we put a little cross. And then it's quite tricky without tracing paper, to be fair. But there are some tricks we can do. For example, you can draw like a little L shape like this. And then if that goes 90 degrees clockwise, so that would be like that direction, right? It will end up like that, right? So it's going to move there. So let me actually do this with different colors. So I'm going to say that the red is the start shape and the blue is where it ends up. Okay, so this corner actually ends up here. Okay, that corner actually ends up there. I can go 3, 2, which will turn into 3, 2. So that bottom left corner actually ends up here. And what do we do here? This is, let's do it like this. 3, 2, will rotate 90 degrees and now become 3, 2. And now that's actually the situation we want. We can now actually just join these up. See, I just don't know how useful it is me going through the questions in this manner. So I think it's probably not the most interesting thing in the world to watch, and there's a lot of technical difficulties, and I don't have the time to, you know, do lots of editing. So I've just got to assume that maybe, you know, maybe 2 or 3 people might watch some of this and it helps them slightly. And that's, I suppose, it's got to be good enough, hasn't it? Okay, so it goes like that. Describe fully the single transformation that will map T. Oh, we've got to label it T, haven't we? Sorry about that. That's what I mean. It's like, it's not very smooth, is it? Whatever. Describe fully the single transformation that will map T back onto shape S. Okay, well, it's going to be a rotation. You could either say 90 degrees anti-clockwise, or you could say 270 degrees clockwise. It's going to end up in the same place. I'm going to write 90 degrees anti-clockwise, because it's just going to go backwards. 90 degrees. Center 5, 4. I mean, that's surely got to be the answer, right? Yep, and the coordinates 4, 5, 3, 7, 7, 7. Yeah, great, super. Right, next question. Here are 2 rectangles. It just tells you everything's in centimeters, and that the 2 areas are the same. And then we have to work out the perimeter of rectangle B. Okay, so when you see a question like this, which is clearly a multi-step question, right? There is no jumping to the answer. One good strategy, you know, there are lots of strategies, okay? And what might work for someone might not work for you, okay? One's good strategy is to think logically. I mean, this is what maths is all about. It's why it's as important as it is. Like, yes, okay, you might never ever need to specifically do something like this, but what it's teaching you to do is to think logically, and that is really very important. So it's like, how would you get the answer? What do you need? What do you need to get to work out the perimeter of B? What do you need? Well, you need all 4 sides, don't you? Right, so we're gonna basically work backwards and see if we can work out what to do. Okay, so we need all 4 sides. So we've got this side, so that's good. So we've got that side, and we've got this side as well. We know what that side is because it's a rectangle, so the opposite sides are equal. And we kind of have this side, but we don't know exactly what it is because we don't know what x is. So then that should make us think, if I knew what x was, I would be able to times it by 2 and then take away 3, and then I'd have this side, and I'd also have the side at the bottom. And so that must then make you think we need to figure out what x is. So the question is how are we going to figure out x? And we're going to figure out x by using this very important bit of information here. It says the area of rectangle A is equal to the area of rectangle B. Now the area of a rectangle will be, width times length. So I'm going to be doing 2.5 times 4x. That's the area of shape A. And this is supposed to be equal to 7 times 2x minus 3. Now, what have you got to remember to put if you're multiplying a whole expression by something? Brackets. That's right. Yes, brackets. Well done if you did that. So this is when, brackets are actually important, right? Brackets are actually important. I'm timesing the entire thing by 7. I would have done 2x minus 3, gotten an answer, and then times that by 7. So the brackets are even brackets like BIDMAS, right? You need this answer before you multiply anything by 7. That's really important. So, okay, we can tidy this up a bit. 2.5 times 4 is 10. So this is 10x. Remember, you'd have a calculator as well. I mean, I have actually got a calculator, so let's just convince ourselves. Yeah, 10. And there's something useful that you can do over here, and that's expand the brackets. So this is 14x minus 21. Remember, 7 times 2x, 14x, 7 times 3, and it's take away, so it's minus 21. What will I do next? Well, now I've just got what's a fairly straightforward linear equation. I will take away 10x, so 0 is 4x minus 21, and I'll add 21. And there's different things you can do to solve this, all right? I'm just trying to make everything be positive. You could have also taken away 14x, and you'd have minus 4x equals minus 21, but you'll get the same answer. So x is 21 divided by 4. Well, 20 divided by 4 is 5, so it's 5 1/4, it's 5.25. So it's like, great, we know that x is 5.25, and that's super. So this side here is 2 lots of 5.25 and then take away 3. So 2 lots of 5.25 and then take away 3 is 7.5. So the perimeter of B will be 7, add 7, add 7.5, add 7.5, which is 14, add 15, which is 29. And it's probably one of those sneaky questions where you have to put the units. Okay, so all measurements are in centimeters, so I'm going to write that it's 29 centimeters. 29 centimeters, great. And actually, as it happens in that one, there wasn't a mark for writing centimeters. I wonder if in the actual question, there's an answer line. Let's just check. Yeah, in the answer line, it's already got the centimeters written for you. Right, so you could have just written 29 then, obviously. Okay, right, number 4. Let me just quickly hide the calculator here. So it's a fair 4-sided spinner, but 3 of them say A and 1 of them says B. We spin it twice. We don't change it in the meantime, and the result of the first one doesn't affect the result of the second one. So it's literally just going to be 3/4, 3/4, whoops, 1/4, and then 3/4, 1/4, 3/4, 1/4. Then it says work out the probability that the spinner will land on A on the first spin. So that means we've gone down this path. And then B on the second spin, so that means we've gone on this path. And do you remember what you're supposed to do as you go across a probability tree? I mean, there's like, what, only 2 options, and only one really makes sense. Because say you thought you add them, it just doesn't make sense to do that. It just doesn't work. Because you do 3/4 add 1/4 and you'd get 1. It's not certain though, is it? So a common sense check rules that out, and you remember, oh yes, I've been taught this several times. I multiply as I go across. Okay, I multiply across the probability tree, and then I'll add up at the end. Okay, because for AND type questions, or events I should say, you multiply, and for OR type events you add. So we want an A and a B, so I do the probability of A on the first one multiplied by the probability of B on the second one, because I want both of these things to happen, so I multiply. Okay, so I literally just do 3/4 times 1/4, which is 3/16. Great. Right, number 5. S is pi squared, lots of b squared minus a squared. A is 8, b is 10. Calculate the value of S. Okay, well, is this not just literally plug this into your calculator? So pi squared brackets 10 squared minus 8 squared close brackets equals, and it wants it to 3 significant figures. So let's write down the answer, or maybe I'll do this. I'll just be very sneaky and actually copy and paste that. Okay, so there's my answer. Now to 3 significant figures. Remember, for significant figures, you come in from the left and you start underlining from when you first hit something that isn't 0. So that actually didn't take us very long. It starts with a 3. We're going to underline 3 digits and then circle the digit that comes after. That's the decider digit. The decider digit is 4 or less, so it's going to keep this 5 here the same. So my answer is 355. Right, number 6. Blue vans, white vans made in a factory. The ratio of blue to white is 4:3. Write down the fraction of vans that are blue. Right, so, okay, I'll just say the answer. The answer is 4/7. If you want an explanation, remember the very basics of ratio, and if you want some revision on ratio, I've uploaded recently some videos on ratio that explains the very basics of ratio. Basically, what this ratio 4:3 means is 4 blue vans get made, 3 white vans get made. 4 more blue vans get made, 3 more white vans get made. 4 more blue, 3 more white. 4, 3, 4, 3, 4, 3. So the blue is going up in the 4 times table, right? It would be going 4, then 8, then 12, then 16, then 20, blah, blah, blah. The white vans will be going up in the 3 times table. And every single time you get an extra 4 blue, you will have an extra 3 white all the time. So when one cycle is complete, how many vans have you how many new vans have you made? You've made 7 new vans, 4 of which are blue and 3 of which are white. So the fraction is, well, it's you know, it could be 4 out of 7, or it could be 8 out of 14, or it could be, you know, it could be 12 out of 21, right? The total number of vans is increasing by 7 each time, and the total number of blue vans is increasing by 4 all the time. You have all of these equivalent fractions. You could write down any of them. Let's write down the simplest one. For blue vans, the number of small vans to the number of large vans is 3 to 5. Work out the fraction of the number of cars made in the factory that are blue and large. Okay, so there are lots of different ways of doing this as well. This is what makes this a bit frustrating in a way, because when there are so many different good ways to answer a question, it's hard to choose the best one, if that makes sense. So I'm just gonna answer it the most natural way that I can think, and that is 5/8. Right, can you see that? 5/8 of the blue vans. So let's write this down. 5/8 of the blue vans are large. But that's 5/8 of 4/7 of the total number of vans being made in the factory, right? 4/7 of the vans in the factory are blue. So we have 5/8 of 4/7 of the total vans of the factory. Right? Think about that. We have all these vans. 4/7 of them are blue. 5/8 of those are large. So it's 5/8 of 4/7 of all the vans made in the factory. What does of mean on a calculator? Ah, yes, means times. So I'm going to do 5/8 of 4/7 and get my answer 5/14. Now, in terms of other ways to explain it, do you see this 8/14 here? It's an equivalent fraction to the 4/7, and it just so happens to be shareable in the ratio 3:5. You'd have 3/14 to 5/14, and the 5/14 is the one that's large. So that there's also that as an explanation. Loads of ways of doing it, loads and loads. Anyway, back to foundation only. So again, if you haven't done this question, have a go. This could easily be on a higher paper. Linda recorded the temperature at 9 AM on each of 30 days. We've got the range of temperatures and then the number of days, and we're going to estimate the mean temperature. So I'm just going to do this this straight away here. So we need the midpoint. That's why it's an estimate, by the way, because these 3 days could have all been 12 degrees, or, you know, 2 of them could have been 12 and 1 of them could have been 10.5. We just don't know. We have to estimate that they were all 11, that they were just all the middle value, because that is our best guess, right? That it's our best guess that they were all midway. So halfway between 12 and 14 is 13, then we have 15, then we have 17, and then we have 19. And then we have frequency times the midpoint. So what's the idea here? We have, you've got, what you've got to think is you've got this huge number of different numbers, 30 numbers, and you want the mean of them, okay? You want the mean of them. So you'd have to add them all up and then divide by 30. 3 of them are 11. So you've got 11 add 11 add 11. So you've got 3 times 11, which is 33. 8 of them are 13. So that's 80, that's 104, I believe. I don't trust myself. 8 13s, 104. Yeah, I should have trusted myself. Right, 14 15s is, I want to say 210. What do you reckon? Do you think that's right? Well, 15 15s is 225. So 210, right? 4 17s is 2 34s is 68. And 119 is, I believe, 19. So, the 3 11s add up to 33, the 8 13s add up to 104, the 14 15s add up to 210, the 4 17s add up to 68, and the 119 adds up to 19. So, what do they all add up to? All 30 of these add up to. This is where we really will use the calculator. So, 33 add 104, add 210, add 68, add 19, so 434, and then it's 434 is the grand total of all of this divided by 30. So I need to divide this by 30. So 14.5 to 1 decimal place. Let's make sure that's right. Yeah, great, okay. Right, then number 26. So the square is inside the circle. The square has side length 8. And we want to know the total area of the 4 shaded segments. So let's just make a few observations, right? If we knew the area of the circle, so this is like that question from before where it's multi-step. You can't just jump to the answer. So you need to get it clear in your head, the pathway to getting the answer. If you knew the area of the circle, and if you knew the area of the square, you could do the circle take away the square. So let's focus on that. So the area of the 4 segments, which is what we want, remember, this is actually what we want. That's going to be the area of the circle minus the area of the square. Oh, I'm writing where I am. Wait 1 second. Right, area of the circle minus the area of the square. Now the area of the square is actually really easy. The area of the square is 64 centimeters squared. Okay, because it's 8 times 8. So the area of the square is actually pretty straightforward. The area of the circle, however, well, we need pi r squared for that, remember? So pi r squared sounds like area to me. That's for a circle. We need the radius. So this is like the mentality is, gosh, if only we had the area of the circle. If only we had the area of the square. Then I could take them away. Okay, great. I've worked out the square. Great. And now it's like, oh, I need to work out the radius, because if I know the radius, I can work out the area of the circle. So now the question is, work out the radius. So we're going to have a radius. I guess there's a radius here and a radius there as well. These are all right angles. And this is definitely, I mean, this is, I believe, the last question in the foundation paper, so it is a hard question. I actually just need to post something on Teams, and I'm not interrupting the video. So what I'm going to ask you to do, just while I'm quickly doing this, is you can let the video play, and I want you to have a think, how do you work out the radius, given that this here is a right angled triangle, and you know that this is 8. Okay, so let me just quickly do this on Teams, and then I'll be back in a sec. Right, done. Okay, super. Okay, did you work out what the radius was? Did you work it out? Well, let's have a look. We're actually going to use Pythagoras. So what we've basically got is we've got r squared plus r squared equals 8 squared. Okay, because it's a right angled triangle, r squared plus r squared equals 8 squared, right? 8 is the hypotenuse, so we have to put that there as the c squared. So what's this? This is 2 lots of r squared, and this is kind of the key thing you need to be able to do, right? What is r squared plus r squared? There'll be a bunch of people who straight away they think it's r to the power of 4. It's like, no, that's not what it is. That's what happens if you times them together, okay? If you do r squared plus r squared, you have 2 of them, and it's just 2r squared. 8 squared is 64, so we can figure that out. So r squared is half, so half both sides, so that's 32. And okay, we could square root 32 and get a surd or convert it to a decimal. Another little question I have is, do we need to work out what r is? Remember, we actually just want to know what pi r squared is. Okay, great. No, we don't need to know what r is. We just actually needed to know what r squared was. And we know what r squared is now. It's 32. So this r squared is actually just 32. So it's 32 pi take away 64. That's what it is. It's 32 pi take away 64. So that would be the exact form. It wants it to 3 significant figures. So let's do that now. So it's 36.5. Okay. Centimeters squared. Gosh, yeah, maybe the answer. Again, the answer line probably has it, but if not, you should write it. Okay, great. Right, how long's the video? 45 minutes. Okay. Well, you don't need to watch the whole thing, and you can break it up. You don't need to watch it all in one go. Find the reciprocal of 5, so we just need to do 1 divided by 5. So you could write a fifth, or you could write 0.2. It's up to you, whichever you want. Reciprocal of blah blah is 1 divided by blah blah. That's what the reciprocal means, okay? So and it just so happens that the effect that has on a fraction, the effect that this has on a fraction is it flips it. But the actual definition of a reciprocal is 1 divided by that thing. Okay? If you want to remember it just as it at the flipping of a fraction, that is also fine. That is what it is. So you'd write 5 as 5 over 1 and then flip it to a fifth. Right, next question. Use your calculator to work out the cube root of 5 tan 60 plus 1. Okay? So the cube root button is here, and I have to press shift first. So cube root of 5 tan 60 and then plus 1. And it's all inside the cube root. So as you can see there, it's all inside the cube root. So what do we get? I'm going to, again, cheat slightly and just do this. There we go. Right, number 8. We nearly finished. Make t the subject of this. So let me write it down. P equals the square root of a plus t over 2. We want to try really hard to get close to t. So t is embedded within a square root. So let's get that the square root is also by itself, which is a good start. So we can just square both sides to get rid of that. So p squared is a plus t over 2. Choice of things you can do now. You really did need to start by squaring, but here we could take away a and then double, or we can double and then I guess take away 2a. It's going to give us the same answer. I'm going to do what I think most people will have done, and that's to take away a. So p squared minus a is t on 2. And then finally, t will be 2 lots of p squared minus a. So you could keep it like that if you want, or you could write it like this. Right, and then I'm going to skip a few. If there are any that anyone wants me to go through, I'm more than happy to. I'm just going to go through this one because it's a good opportunity to remind everyone about SOHCAHTOA. So anyway, the length of QR is 60% the length of PR. So what should we say? Should we say that this is 100% and that this is 60%? Seems like a fairly reasonable thing to do, right? QR is 60% of PR, so I'm going to write 160. Then it wants sine of QPR, so QPR, it wants sine of this. And we'll start by writing down SOHCAHTOA, because we're going to see that there's a little bit of extra work to do. Not too much, but a little bit. We need to use SOH, so sine of theta is opposite over hypotenuse. And then the first thing really that sort of should stick out is we don't know what the hypotenuse is. Like, we don't know what the hypotenuse is. We need to figure that out. So let's figure this out. So how are you going to figure out the hypotenuse of a right angled triangle and you've got the other two sides? That's right, yes, Pythagoras. Okay, so I'm going to do 60% and square it. I'm going to add that to 100% and square it. And maybe it's a bit overkill really to be sticking the percentage signs on as well, by the way. Like, you don't really need to. Like, just make everything 100 times bigger. It's a similar triangle, so it's still going to give you the same answer. Is 60% of 100? Yes, so you can make them be 60 and 100. So let's do 60 squared plus 100 squared and then square root that. So 60 squared plus 100 squared and then square root that. So I get 20 root 34. Okay. So it turns out that that's 20 root 34. It's a third. And then we can finally say what sine of this angle is. So sine of QPR is the opposite, which is 60, divided by the hypotenuse, which we've just worked out is 20 root 34. So if I actually type that into my calculator and then write that down to 3 significant figures, I'm going to have the answer. So 60 over 20 root 34 is 0.514 to 3 significant figures. And I'll just check the answer. Right, great. Any other questions? Anyone wants me to go through anything? Just let me know. Otherwise, hope this was useful. And yeah, I'll see you later. Bye-bye.